Terrific. So today's webinar, sponsored by the NIDA P30, is on using the R language to dig deeper into your data. It'll all be in the context of genetic data sets, but of course R is a generic tool derived from S originally that is seen very widespread adoption over the last couple of decades in bioinformatics and all other facets of stats. And we have two pros, two statisticians. I will introduce Saunak Sen, who I've known for quite a while, and then Saunak will introduce Gregory. But just quick comments on Saunak. He's given quite a few of the webinars in this series. So if you're not familiar with those webinars, just go to opar.io, where you aren't there today, but we'll put that in the chat. Let me just put that in the chat for you. opar.io, there it is. There are a series of 13 plus webinars there. Saunak has given several of them, Laura's given several of them, and a more extensive community of colleagues of ours have given talks. I think Abe Palmer gave a talk just a couple of weeks ago, so have a look at those. They tend to be quite, they're oriented around techniques and resources for doing substance use genetics, substance use disorder genetics. And so they're not really just standard talks about a research program. They're more talks about how to do X. And I think this session is a perfect example of how to do X, in this case using R. So Saunak is a statistical geneticist trained at Columbia for part of his work, and then did a postdoc with Gary Churchill at the Jackson Laboratory in the late 1990s, and then was a faculty member at UCSF for many years. And we were lucky enough to recruit him to UTHSC 6 years ago, Saunak? About that. And he is now the section head of biostats at UT. He tries to do everything. He tries to be a good citizen to the community, which poor statisticians, they tend to get abused as good citizens of the community. Everybody comes at them with their problems, but he's also a true research, quantitative statistical geneticist, making real contributions at the cutting edge that he won't be talking about today, I don't think, since most of his cutting edge work is in Julia, another programming language. But Saunak, thanks, and take it away.
Thank you, Rob, for the introduction. And we are grateful for the P30 to broaden our horizons and to make hopefully a broader impact. Today's lecture or today's talk will be about introducing R if you are somebody who's not already using R. So we'll cover kind of like give you an overview. It will be more like a 1-hour ad or 40-minute ad for R more than anything else. I'm joined today by Gregory Farage, who's going to lead actually this talk. I'm his assistant today. He is electrical engineer by training. He got his bachelor's in engineering in electrical engineering from Lebanese American University in Byblos, Lebanon, followed by a master's in digital signal processing from Telecom Brittany. I cannot pronounce the French version of it, so I will use the English version, from Brest, France. I know Brest from the very famous bicycle race, actually. And he got his Ph.D. in remote sensing from Sherbrooke University in Quebec, Canada, at the Center for Research and Applications in Remote Sensing. Rob actually introduced me to Gregory a few years back, and he's been working with me as a postdoctoral researcher, and complete change of field for him. And he also helps me teach the introductory R course that we teach here. So, he's going to lead the discussion today on R. And Gregory, over to you.
All right. Thank you, Saunak. All right, so I will share my screen. So can you see it?
All good.
Yes.
All right. So thank you all for coming. So today we'll have a brief tour in R. Don't feel shy like to send a chat message, like if you have a question or anything like during like the presentation. So I guess that today you came to this presentation, to the webinar, because you don't know what is R and what does it look like, what are the capabilities, or you know what is R, but you want to know a little bit more, have more insight of what it is, how to use it, or maybe you heard about Rstudio and what is the difference between R and Rstudio and how you can use it. So we'll try to cover those questions. I will explain like why it's interesting and to use what are the advantages to use R or to learn R. I will show you also quickly like how to install R and Rstudio. I will try to go over like the R basics, like basically like what are the basic concepts that you need like to grasp to make your learning process the best in R programming. We'll talk about like the R packaging, the R package ecosystem, what they are, where to get them. And we will finish by a small basic statistical analysis example, like to show what you can do with R in some data analysis contest. And we'll talk a little bit, I will show you like some resources that you can find online. So first, like what is R? Okay, so R is a programming language, but it's like an environment for statistical computing and graphics. Like Rob just told before, originally R was actually created in 1976 by John Chambers in the Bell Labs. So known like AT&T centers, or now it's known as the Lucent Technologies. So he created this computer programming specifically for statisticians. And 10 years later, they commercialized a version of the S programming called S+. Actually, you can still go on their website and buy a license, like to use the S+ programming language. In 1991, there is two great statisticians, Ross Ihaka and Robert Gentleman at the University of Auckland in New Zealand. They developed the R, which is like a dialect, basically, of S. It's an alternative implementation of this language. And few years later, Martin Meckler convinced them like to make R, this language that they implemented, free and open source. And from this point, the R become spread. And in 1997, there was the first announcement of the comprehensive R archive network, which is like the official website to download and install the R program. At this time, there is only like three servers where you can download it, and there was only like 12 packages. And a little bit more than 20 years later, We are at the version like 4.04. There is 105 server worldwide, like in 49 countries, and there is a little bit more than 17,000 packages. So just to let you know that this timeline was actually generated in R with ggplot. So now today, like, yes, R is a very popular tool, but why? Because simply it excels like in statistical function and modeling, and also in visualization. So it's widely used in academic and research fields, but also it is used by top-tier companies like Google, Facebook, or IT companies like Accenture, IBM, and even like financial institution like American Express or Bank of America use R for different analysis or visual graphics. So why R is so popular? First, it's open source. So it has a transparent algorithm. You know what there is under the hood. It is great for to reproduce data analysis. And by that, I mean, like, imagine that you do a data analysis that you can even publish, and like 10 years later, you need like to rerun this data analysis, or allow you to take like a snapshot of the version that you use to do the analysis. And 4 years later, you can use this snapshot, and through their network, it will reinstall and go find for yourself, instead to do it yourself, like to install all the version that you use for this specific data analysis. So this is really great for that. It's free, so which is like a very good and very important advantage. And also it has the package, so it's libraries, the function that can offers like for the users. It's very large. It's extremely large, and it's one also it's what makes R a very competitive programming language in data science. And you have access to advanced libraries, and by that I mean like there is the cutting edge, meaning like there is a lot of scholars, like when they develop and publish their algorithm or methodology, well, often they can, in some field, of course, like they develop a package, and you can have access to these packages. And it's extensible by the user, meaning that you can use those packages, you can use function, you can add your new algorithm, you can share it with the others. So it is great. And for the last, I will say, like, it is a great language to start programming. Like if you're not a coder or just begin to start to program, there is a lot of tutorials. It's really rich, and it is free also. And there is a large community that can help you to solve bugs or interpret package functionality. How? Basically, there is some forums. You can go and ask your question, and usually very fast you will have like people trying to answer your question and help you to resolve your problems. And most of the time, I did never have like to ask question. The question was already asked by other people who have similar problems, and I could find my solution there. So here we see like how to install R. So you go to the CRAN project, you go to the website. It's very straightforward, depending on your operating system. For example, me, I'm on Windows right now. You go there, you click here, install for the first time, you click on that, it will download the installation package. Like any other software, it will install it straightforward. So let's see now what R look like. And I want to show you what R look like, not in Rstudio, because Rstudio is not R. Rstudio is just a software that uses R for making your experience of programming much easier and much more user-friendly. So let's see, like when you open like R, when you install it like on Windows, what it looks like. It's just like a console, a terminal, where you have here, we can see like what is important to note is basically the R version and the date of release. And you have always, like, next to the date of release, a name for the version. As a side note, there is a story behind every release name. There is a blog written by Lucy D'Agostino McGowan, who basically explained that behind, like, every release name, there is a reference actually to peanut, strip, and films. So you can go over the blogs and see what were the different names for the release names or the version, and what are, like, the different references. It's very nice, and if you, like me, you like peanuts, it's like it's very funny. So now we just show you, like, what R looks like. So what is this? What is this console? Basically, it is like what we call it an interpreter. In interpreter, it means that here you will write a piece of code, and the interpreter will get your command line and will translate it to the computer so it can compute and return the output or the answer. Like, you can use it as just a simple calculator, 1 + 3, enter, = 4, and so on. So, but this is just the R. But if you want to program, get some plot, have a nice visualization, what we need to use, it's what we call an IDE, which is like an integrated development environment. And for that, we will use Rstudio. So how to install Rstudio? Also, it's very straightforward. You go to their website, you go to download. Here you have a free version. So in free version, you don't have support, basically. If you click download, it will automatically detect, like, what is your operating system, and you will have access to the last version of Rstudio. So next, let's explore Rstudio and see. Let's see what it looks like. So when we open Rstudio, it will open. It will be like this. So here we have, like, the same console that this is our interpreter. Here inside here we have the window which is called environment, and the environment basically will give you information about, like, your variables that you create or your data set that you loaded in R. You have access also to tutorial. They are very good tutorial, like, through different by using Rstudio, through different package and also different concept. You have an history. So this history is just an history of the command line. For example, if I do my 1 + 3 commands, it will appear here. And then here, what if I want, like, to save a value in a variable? I will do this. I would say, like, for example, my var, which is, you have to declare a name for your variable. Your variable, basically, it's a container. It's just like a space in your computer, in the memory of your computer. We're saying, like, okay, this space, I want you to save this value. And now, in the environment, you can see that I created a variable, and you can also see the value in these variables. So you can code like this. You can apply different functions. You can also, for example, if you want to use the value in your variable, you would just put my var. And if you want to add, like, just multiplied by 2, multiplied by 2, for example, like this, and you will have your results. And you can do, this is very simple, of course, but you can have, like, much more advanced features. You can apply, like, different mathematical function. And when you do that, basically you will go through your your command lines. So, like, if you can see, like, everything that I have done in my history, and if I want to do something else in the past, so you can see that it's not very, like, easy friendly to to just do your analysis just using your console. So what we do, we use what we call a R script. And by default, when you open your Rstudio, it will create a blank R script. The R script is just a text file where you will have your command lines, and you will be able like to run your command line. You can like select, for example, here I can, if I do like my 1 + 3, you can select this. Here you run it, and it will run. It will copy paste run it in the console as you see. So I will open now as an example a script that we prepare for the webinar. So here are my script. Here's my script. So this is programming, so don't be scared, okay? So yes, it looks like, wow, there is a lot of things going on here, and I don't know if you're not ready for that. Well, so here what is important to see, it is like first, like R is a language, so there is like syntax. There is syntax means there is spelling and grammatical rules. And one of them is like when you use the hashtag, this, it means that is a comment. A comment, it means that when I will run this script, the interpreter R will ignore like the line where there is the hashtag. So why do I have comments? Well, basically is to help like any user, like or someone who I will share with the code, so they can read and understand like what I was supposed to do, what are those, what I was planning to do with those different commands. So I will not go through like all the code. I will just run it to show you when you run it, what you can get. So to run a script, you can select like a specific line and just run it, or I can just source it. And when I source it, it will run all the script. So here, what is it doing? It is here it's like loading some packages. Here it is reading some data set, like it's a mouse data set. And I will extract like some information from my data set to get like the fasting glucose level, and I want to plot it. I want to make a special plot where I will plot my fasting glucose level according to the sex, and then after you can get like this kind of plot. So in the plot here, when I run this actually appeared here. And here, for example, I have like it's a customized plot where I have half of it is a violin plot, and half of it is a strip plot. So this just like quick example. So Saunak will give you a more. We'll continue the story of those data through a data analysis example later on. So just other features of Rstudio, they are here, the files you can browse in your computer. Here you have packages, meaning like they are my libraries of different packages. I will explain it later, but packages, basically, they are a set of functions that have a that offer a specific task. And here, if I want to load my package directly from the interface, I can just have like, for example, click on this, and it will load it. And you have the help. So also I will give later on an example on how to use the help, like in Rstudio. Other thing, it's like in R, there is R script, but there is a lot of different other kind of files that you can open. Most recently, you can use it for Python, and you can make also presentation with R. And actually, my presentation was made with R. So we saw that like if you want to save a variable, we use like the arrow symbol, right? And we store a value in this variable. So this variable has a value, but it has the value also as an attribute that is called the data type. So the data type is to help like the interpreter like to show how you intend to use those variables in your programs. So for example, here, if it is a numerical data type, an integer or a numeric, so your computer expects you to do like some mathematical, for example, calculation or computing with this. Or you can put like characters, okay, so it is a string. You can store a text, and for that you have to put it between quotation. So here it could be just one character, or it could be like a word, or even like a sentence or a paragraph, and it will store it in those space in the variables in your container. So another important data type is the logical. So the logical is a Boolean. So what is a Boolean? Basically, it can have only two values, true or false. And why we need those kind of data type? Well, when you are going to program, at one point, you may end up like to have a situation where you want to decide if, let's say that you have a situation where you want to say like, if I have this value equal to this, for example, greater or equal to 9 or whatever, I want you to do these comments. But if it is not, so it is false, do something else, or just don't do nothing. So the Boolean is just like a flag to tell you if it is true or false, to switch between your code or ignore some part of the code, or just run an alternative option for your code. So you just like it's very useful, but even if it is conceptually you think it's complicated, but actually it's easy. But here I will not go more in detail about that, but in tutorials you can check it. So we saw like what are the data type, and now I will explain what are the data structure. So the key concept for programming, they are the data type, data structures, and how to use and write, how to work with function. So the data structure, it is like a layout like to organize all your values. Meaning by that, we saw that if you have just one value and you want to save it in one variable, we saw it like it's very easy. But what happens like if we have a set of variables, a collection of data, how we store that in your computer, and how the R program, the R language the R system will use it, so you can have access to that, to them, and you can use them for your data analysis. So well, there is like some structures, the vectors, factors, matrices, lists, and data frame. So the easiest data structure is the vectors. So the vector is basically a collection of elements. It's just an array of elements. They have the particularity that they must have like the same data type, meaning that your vector will be a vector of character, a vector of numbers, and so on. So here I did like a small example where I used the function, just to call it like the C function. The C it means for concatenate, meaning that it's like to assemble, to combine elements together in just one place in the vector. Here I put like vec1, you can put any name that you want, of course. Here I did another vector with numbers. And what happened if we mix like the data type? Well, because it needs to have only one data type as an attribute, it will decide for us. So because it cannot interpret the word test as a number, so by default, it will assume that the other elements in your vector will be also characters. So the factors basically is the vectors where we have assigned labels for category. So it's to store categorical data, and in the factors, those categorical categories labels are called levels. Here, another important data structure is the matrix. So the matrix is just like a two-dimensional array of data. So one way like to create it in R, it's basically you use the C function. So this will basically create a vector, okay? But you will indicate like how you want to spread them in a matrix. So you can indicate how many rows you want, how many columns that you want, and you will get your matrix. Or what you can do, you can build it like more manually. You can use the cbind function. So those are very basic function where what you're doing is column binding. You column bind like vectors together. So you have like a small here vector 1, 2, and I bind it with the 3, 4, 5, 6, and 7, 8. Or you can do it row-wise with rbind to, and here it will be combined row-wise. The list is the most flexible data structure in R. So basically a list, the element in your list, they don't have to be the same type. They can be of different, you can combine different data structure. Like for example, here in my list, I included like a vector. You can see here a matrix, and you can even put like any object that exists in R. An object, like for example, a function. When you created a function, it's an object. So it means that somewhere in your memory, there is a name with your function. So like here it's sum and has a functionality. And basically you can save like anything in a list. So it's very flexible. And you can also add some names to your elements in your list. Then after we have the data frame. So I think the data frame is the most important data structure in R. Why? Because when you are going to read your spreadsheet, your data, it will be, especially if it is stored in the tabular data, you will read it as a data frame. So what is a data frame? It's just like a list, but only of vectors. So it's like vectors combined with each other, and each vectors can be of different type. So for example, here I created a vector of with the months, a vector with the day, and I will use data frame. It will combine them, and it will create like my data frame where I can see that I have my month and days here. So now, how can we have access to those data structures? Because now we created them, we stored their values in the memory of the computer, but how we can use them, how we can extract the information, and how can we modify those values? Well, it's very easy. You just need like to have the name of your variable and add like some brackets to it. And when you do that, you will indicate inside the bracket, you have to indicate like the position of your element. I'll give you an example with the vector so you can see. So I created the vector 1 where I have those 3 elements, and I want to have access to the second element. So here I will just write vec1 square bracket, and I want to get like my second element. So it's very easy. And if you want to have access to more than one element, well, you will have to, in the bracket, the position, you will have like to write the vector of your index. So using the C function, this will give you like the collection of your position. And here, for example, I will have like March and September. So for accessing the vector from a factor, it's like exactly identical like of accessing the element of a vector. In the case of a matrix, because we have it's two-dimensional, so we need to give like the 2 dimensions of our structure. So meaning like the row and the column. So here it's row number 2, column 3, and here I have my value, which is 6. So now what happens if you want like just to subset like just one column or one row? Well, what you do, you just omit to give like any index. Like for example, here I omit to write the index of the row, and I will get like the column number 2. So it means like all the rows in the column number 2, so 3 and 4. So if you want more than column, like 2 columns or different sub values from different places in your matrix, you can give the collection of your indexes, like the coordinate of your values in your matrix. So to access element in the list, basically is still bracket, but here you need to use double bracket, and you just indicate which element you want to have access in your list. So in case of the data frame, well, there is 2 ways to do it. Like in the matrix, you just need to put like the row number, the column number, and here it will be like July. Or what you can do, and most of the time we do that, like especially if it is a small data set, we use the name of the column. So here the name of the column is month, so I will use a $sign after the name of your variables that contain your data frame, and you use your square bracket to indicate which element you look for inside this column. So now if you want to modify your data frame or modify the value in the data structure, well, what you need to do is just like use like the way to get access to the value. So here, like, let's say I want to change March by April. So is my first element in the first column, and I will assign with the arrow, I will assign my new value. So it will save the new value in your memory. And I will do the same for the day. I will replace 7 by 5. And now my data frame has this different value in memory. So we saw like the data type, the data structure. The other very important concept is the function. So the function, the function, and we saw like some function, like for example, the C function or data frame function. It's basically is built-in function that you can use in R. So I want to show you quickly in Rstudio, like for example here, let's say that I want to have the square root of a number. There is a function called square root. I will put 9 and it will give me the number 3. So the function, you have an input, or sometimes you have more arguments inside this function. It will process those arguments and give you back an output. So a nice analogy between the data type, the data, the programming function is like a little bit like cooking. Like when you're writing a program, it's like you are writing a little bit like a recipe. It's a recipe. Your data set or your data, they are like your ingredients. Your variable or data structure, they are like your bowl or your dish where you will put your ingredient. And the function, they are like the utensil that you use to process those ingredients, like an oven or a mixer. And when you do that, you end up with the new results, and what will return in your function after processing your argument is the output of your function. So actually, I will say that programming is even easier than cooking, in the sense that you take one recipe and 2 different or then 10 different users will use the same recipe, will end up exactly with the same results. But not necessarily the case when you cook. So here in programming function, I will just show you like a small example. Let's say that if I want to write a square function, here I would just put like give a name to my function. That will be my input. The variable, it's like a temporary variable names. I will take these variable names, I want to the power 2, and I return the results. And when you do that, after in R, you will be able to call your function, put whatever value you need to be squared, and you will end up to have the results. So another important thing like to do when you do your data analysis, actually is the first step is like to read your data. And to read your data, well, we will use a function to read your data, to load your data in our system. So usually your data, they are on the form of a spreadsheet. So it could be Excel files, or it could be a CSV file. So CSV file, for the one who doesn't know, is a text file where basically your elements of your spreadsheet, they are separated by commas inside the text. So you can have different formats, and here there are like built-in function like to read those data set. So now you know that there is this function, but you are not sure how to use it, or you don't know even like if the function exists for something. So here you can put like in the help, you see when I start like to write my function to get the help of this function, you start like to give me like an auto completion of this function, like options, and I will write read CSV, and here I will have like the description of my function. So how to read help in R, also that is also important. So here what is say, I see my function here, but I see also like there is other function. So basically what it means that your R read CSV belongs to a family of functions that share common input arguments. So all of them will read files, but they may have different arguments. Meaning that here, for example, in the CSV file, the separator between the element is like a comma. But in read the lim, it could be like this means like a tab, or it could be a semicolon or anything. So how do you see like you have like you look at it here and you have a lot of information. So what is important, what is not important? If I'm going to use this function, should I write all of this, or just like what exactly? So well, what you need to watch is like here, if you pay attention, the only argument that does not have an equal after the name of the argument is file. So it means that is the argument that is required to run the function. So if I put like read CSV or read table with my file name, this should be enough. So the other arguments, they are options. Like for example, header. So what is header? Header equal true. So what does it mean? So if you go there, you will read that header means that does the first line of my data set contain the name of my variable? Yes or no? So if it is yes, it will load those names in your data frame. If it is you put false, basically it will create a new one for you. or the files. What is the files? What should I write it like this? What is it? So basically, is the path. You have to write the path of your file. Where is the full path of your file in your system? So R know where to go and look at it and read it for you. So you have a lot of different formats. You don't have this like Excel format. So if you are, there is not like a built-in function to read the Excel's files. So what do you do? Well, that's where you use like packages. Like packages is the bundle of function of documentation and sometimes the data that they are developed to add like a specific functionality. So let's say that I know that there is a package, or I went to Google and I Google, like in Google, by the way, it's a great also way to find help for R. I will say like read Excel files in R, and probably I will end up with a link saying that there is a package called XLSX. I will install it. So install the .package, you give the name, and it will go in the official website of R and retrieve it, install it for you in your machine. And when it is installed in your library, to call it and use it, you just have to write library, the name of your package, and then you have access to a function that will be probably read.excel. And you can read the documentation to see like what are those different functions. So another great website for packages is Bioconductor. So let's say that you want to do like an analysis, you want to do a principal component analysis, or you want to do like use certain algorithm for a method to analyze your DNA, your SNP, or other data. And if it does not exist in the packages in R CRAN, you can always go there. Here, there is a lot of bundle of packages. On the website, you can try to put keywords, and you will find how to install it if it is not directly from R CRAN with the function I just showed you. And you will have the documentation, and you will have the references, meaning that if their paper was published presenting data using this package, you can use it here. So now we saw like the different concept of programming, of the data structure, the packages, and I will let now Saunak like to show you like a basic statistical analysis example. Like just to show what the capabilities that you can do with R. So Saunak.
Thank you. If you stop sharing, then I will start sharing.
Okay.
Thank you, Gregory. Can you see the screen here?
Yes.
So I'm going to do a very quick analysis of a data set that we have already seen previously in this series of lectures. And it's to give you a flavor of what a kind of a basic data analysis in R that you may be used to doing it in other languages or other systems, what it might look like. What I'm going to use today is data from Leah Solberg and colleagues of it's data from a from a rat cross, which had behavioral and kind of clinical phenotypes related to stress and a rat's response to stress in this that's described by Solberg and colleagues. I downloaded the data from the mouse phenome database, the QTL archive. So there is the data set, and supporting information all comes from this website. What you are seeing here is what's called a Jupyter notebook. It is an interface to R and other languages. It's yet another way of using R as well as Python, Julia, and many other languages. And it allows you to mix text and code at the same time. So you can interact and visualize different things. This system is different from what Gregory has showed you with respect to Rstudio. It's a complementary system, and it's going to be the subject of a talk, future talk in our same series. So if you're interested in learning more about Jupyter notebooks, you could join us later in a few weeks. So this is the outline of the talk today here. I'm going to enter this data, do some basic manipulations with it. I will visualize, histogram, scatter plots, and then do some inferential statistics like a t-test, Fisher's exact test, things of that nature. It's you can get the outline over here on the left. I will say in the beginning that this data analysis is more like a toy data analysis. It's not really organized towards a kind of a real scientific goal, but is meant as an illustration of what you could do and the kinds of things you could do. And would also be a way to connect with what Gregory has already done, where he showed you what the language looks like, what the syntax is like, and here you will see it in action, how it might actually feel like if you were to use R. So the first thing in any data analysis is you will be reading in the data set. In this case, I have put this data in on the web in this URL, and I can say DF, meaning data frame, is the output from the read.csv file, the read.csv function, and this is the URL. It could also be, I could get the same thing if I just did this, where this is the location of the same file, but it's on my own computer. But I'm just going to do it from online, so because it's this is the same thing that you can do yourself. Let me show you what this data looks like. This data, if you visualize, like in Excel, will look something like this. This is what we are normally used to when we open up a data set. There's a animal ID, there is the sex, 0, 1. I think 0 is female and 1 is male. And this is PGM is paternal grandmother. This was a F2 cross. So this is the strain identity of the paternal grandmother, which could be either the F344 or the WKY rat, one of the two. And these columns are the different phenotypes that were measured in this cross. And let me also show you what this is, what might look like to you in Excel, but the file actually looks like this. Yeah, it's the so-called CSV format, comma separated value, which is a very portable and widely used text-based format for spreadsheet or any kind of text-based data. So here are the first line is the list of the phenotype names. You have the same things like animal ID, sex, paternal grandmother. Further down, you have weight at 11 weeks, 17 weeks, fast, there's glucose, there's fasting glucose. Oh, where is it? Okay, there's fasting glucose and so on. And the way the data is organized is that every field is separated by a comma. And so that's why it's called CSV, comma separated values. So this is actually what the file looks like. So I read in the data, and I can, just to get a feel for whether I entered the data correctly or not, I can say head, which means just show me the first few lines. And so this is exactly the same spreadsheet that we saw here. It's the same, but it's now within R. And R also tells you what the data type is. Again, Gregory told you earlier, the animal ID is an integer, sex is coded as an integer, paternal grandmother is coded as an integer, but other phenotypes like the glucose measurements, fasting glucose is coded as a floating point or a kind of real number. If I want to get the names, just the names of the header, I can say names, and it tells me the variable names, which is the name of each column, and you can see all of those. If I want to know how many rats there were in this data set, I say n row, which is number of rows. And it's 486. So I have 486 rats in this data set. Now, what we are doing here is maybe a little bit different from what you might be used to in other programs, where you implicitly you're always working with a single data set. Here, you could be working with multiple different data sets. And here, almost everything I do, I have to name the data set I'm going to use. So this is the kind of the cost of being able to analyze multiple data sets at the same time. I have to always specify what data I'm working with. Next, I'm going to take a few preparatory steps. This is not what I recommend that you do, but I'm going to just remove all the rats that have any missing data. This is not something I recommend, but I'm going to do as a matter of convenience here, just to keep things simple. So here I do, and I can, if you are curious what this does, it's pretty drastic. So now I can say n row df, and it says 340. So I've dropped a lot of information this way. So I do not recommend that you do it. I am doing it here as a matter of pure convenience. Then what I'm going to do is I'm going to load a few different packages just for convenience, so that I can work. I have certain functions at my disposal. Those are these library lines. And then I'm going to manipulate the data a little bit, a few of the data fields that I'm interested in, so that it is easier to look at and the labels work nicely. So for example, I'm going to convert the litter because there were multiple litters as a factor. I'm going to make the sex variable a little more readable by coding 1 as male, 0 as female. I'm going to log transform the fasting glucose and the weight measurements because they behave a little bit better if transformed. And note that I'm using log based too, so that I can easily convert to grams in my head more easily. After you have entered the data set, the first thing you will do is to visualize the data, right? So I have already seen how many rats there are in this data set. I might want to see how many rats there, male and female rats there are, and of each paternal grandmother types, 0 or 1. And I can visualize this using a Mosaic plot. So a Mosaic plot is basically this table in visual form, and it allows me to see the area of each rectangle is proportional to to the counts in each of these 4 categories defined by sex and paternal grandmother. I can see that there are a bunch of litters. Here I have about 39 litters I can see, and they are about, between 5 to maybe 11 or 13 rats per litter. If I wanted to visualize the distributions, I can use a function, the histogram function. And here I am doing the histogram of the fasting glucose log transformed. If I did not do I could not have transformed it, but you can see that even after transformation, there looked like what looks like a couple of outliers here. I can now visualize the fasting glucose and compare it with among the males and the females, and you can see that the histogram is slightly shifted for males. That is, males have slightly higher glucose levels. And this is an alternative visualization of the same thing. I could use a so-called Violin Plot, which is basically the same information, but presented slightly differently in terms of a violin. It's basically like the histogram, but it extends on both sides. You can also see here that the males have a slightly higher glucose level here. I can do the same for all the litters just to see if there is variation among the litters. This is called a ridge plot. It looks like a bunch of hills, and you can see that there's quite a bit of variation, but overall it is pretty stable across litters. I wouldn't say there is a dramatic variance, but there are a few litters that are very low, and you can also see exactly which litters had the really high glucose levels. This is the histogram of the weight at 17 weeks, again, log transformed. You can clearly see that the males are higher than the females. And this is a very useful check to also see whether your data is imported correctly. If the labels have been shuffled inadvertently, then you will see no difference in the weights of males and females, but otherwise you should see a clear separation like this. I can also make scatter plots. Here I am plotting the weight at 11 weeks and the weight at 17 weeks, and I see two clouds of data. I have colored the points by their paternal grandmother identity, the two directions of the cross. And you can see that the salmon and green points are more or less overlapping. You could say that the green dots are slightly under the salmon ones, perhaps, but there's not a very striking difference. However, if you color the dots by sex, then you can clearly see that the males and females are totally separated by their weight. Now, I don't actually work with rats, but this seems to suggest that there's almost no overlap in the weight of the male and female rats, which I found is at least slightly surprising. Even at least in humans, and maybe at least the data sets that I've seen in mice, I don't recall seeing this very clear separation. I don't know, maybe somebody else will comment on this later. So next I'm going to do a few, after having explored the data, having felt comfortable that the data seemed reasonable, I can now do some inferential statistics. Okay, let me show you one little thing. Why did I take logs? If I didn't take logs, I would have something that looks like this. But notice, how the variation in the upper half of the data is more than in the lower half of the data. So if you take logs, then that disappears. So for many statistical analysis, that type of stability is desirable. So that's why I would transform the weights by log in this case. Now we are ready to do some inferential statistics, that is, test some hypotheses. This is something you might be used to. One common thing is the t-test. How do you compare the means between two groups? there is a function called t-test, and you give it the outcome that you want to test for, and separated by a tilde, the variable by which you want to split it by. And you also name the data set, which again is the DF. I call you the data frame. Here you can see that the p-value is very, very, very small. Not surprisingly, because there was, as we saw earlier, a very clear separation between the two sexes. If I do the same by the paternal grandmother, then the p-value is 0.1, about 0.09. So you can still see that there is a difference, but it doesn't reach statistical significance at the 0.05 level. I could do the same test using Wilcoxon test, and the p-value is very similar. It's a little higher than what you get by a t-test. If you have two dichotomous variables, you can do a Fisher's exact test. So I'm going to use the paternal grandmother and sex as the two variables for whose association I'm going to test. And you can use Fisher's exact test. You get a p-value of 0.088. If I wanted to do a chi-square test, which should give me a very similar result. Let's see, it would be, I get a very slightly higher p-value, but basically the same 0.09. So this is how you would test the association between two dichotomous variables. If you want to do linear regression, let's say I wanted to do linear regression, I can, that is, I want to predict the week 17 weight using week 11 weight for just the males. Then I would use a function called LM, which is for linear model. I give the name of the dependent variable or the outcome variable, separated by tilde, the dependent or the predictor variable, the data set, and if I am going to subset the data, and here I'm going to subset it by sex. And it, not surprisingly, it shows that there is a very strong dependence between weight at 11 weeks and weight at 17 weeks. And if you wish to visualize how that line looks like, you can plot the two. This is a slightly different plotting scatter plot function. You can plot the two variables and you can overlay the line on top of that. So this is just a very brief outline of what you could do. There are many things you could do, of course, and I will put this notebook online for you in the OSGA website, where we have many other lectures like this. And if you want it, you can use this code as a learning tool. You can just tweak this and do your own analysis with it. And over to you, Gregory.
Thank you. All right. Okay. So between like the small introduction or the concept or small example that I gave it to you and like what Saunak just like showed you, yeah, there is like a kind of a gap, but actually this gap is like not as big as you may think. Once you understand like those basic concepts, and especially like how to read the documentation and understand like when you if you need like to reach more advanced tutorial, or also let's say that if you find out like a script or like this notebook, and this concept will help you like to understand with some keywords, with little maybe documentation, like how to use it, and you can reuse it for your own purpose and your own data set. So here I want just to show you, there is, we put like a lot of resources online that you can find. There is books, very well written books, so some tutorials. So there is a tutorial that are more written for a biologist audience. There is tutorial, they are more, they address more for statistician. So you can find a lot of flavors and different way online to learn how to program R. And here we put some link where you can have access even like to more different kind of resources. So it's, and of course you can always use Google and try like to put some keywords. And this one, this video, I think it's also a great video. It's 2 hours long, like to start, like to, it will go a little bit about like what I talked today, but it will be more in detail and explain even more more basic things. So to conclude, I want to conclude by the pro and the con of the R language. So we saw, I told you before, like the advantage that R is open source. It's there's the, you can use it on different operating systems, so it's very easy like to transfer like your the program from one computer to another. There is a large community, and again, like Rob said earlier, that we also code in Julia. Julia is a more recent language, and we code in both languages, in R and in Julia. But every time, I like the Julia, but that is another story, the Julia language. But R is such easy like to program in R because you have so much examples, so much already recipe code online that you can use, and packages, and the community is much larger too. And R offers like very nice and visualization and interactive tools. It's a cutting edge also programming language, in the sense that a lot of new technology and ideas that for data analysis or in statistic analysis, they first appear first in R, because it's very easy to prototype those kind of algorithm in R. So now the con, first, not all the 17,000 packages are perfect. Some of them, they maybe also they are not working, in the sense that, let's say, if I develop a package, and for 2 years I was like maintaining my package, and I stopped. So maybe there is one version stopped maybe 2-3 years ago. So what do you do? So you need like to reinstall an old version of R, or it's become more complicated. So these are the little things that are, you know, upsetting. But in the same time, there is a lot of function. Like, let's say if you want to do a principal component analysis, I mean, there is like 10 different packages that do it. Some of them, they are already always like maintained. And I will say, like, if you want to choose a package for a specific task, always try to use the one that are also published maybe in a paper, so you have references, and also it means that it's there is more chance that it's maintained. There is no customer support for our language, so if you have problems, your only help that you will have is the large community, so which is good, but not an official one. And I will say also that R was designed for interactive data analysis. So if you end up with like a very, very large data set, where it needs like very high computational analysis, that may require some additional adjustment, like to be for your memory management or the speed of your data. Well, I mean, thank you, and I will be glad to take some question now if you have any question. Thank you.
I have a question.
Yes.
So first, thank you so much, Gregory and Saunak. I've been a long time user of R, and then know some of the facts that you mentioned. So thank you so much. That was great. So a bit of my story and then my question. So I started working with MATLAB. Of course, I'm an engineer, so engineers typically start working with MATLAB. Maybe over 15 years ago, and then it was maybe around 7 years ago that I started working with R, and I found it very useful, I was comfortable with R much more than MATLAB, that I pretty much never got back to MATLAB unless I had a program that I had written and I had to just get back to. And then it was about 5 years ago, 6 years ago, that I wanted to work with deep learning models. And at the time, pretty much nothing was in R. So R was great, better than MATLAB for me until I wanted to use deep learning. And then I had to switch to Python. And I found Python a very useful language for, particularly for deep learning, and also for some of the machine learning models. But still, I'm more comfortable with R. And whenever I can just program, I just go to R. Otherwise, I can just for example, do that in R, then I switch to Python. Now my question is that, do you pretty much have the same feeling of these three programming platforms? And also, do you have any comment on, recent developments in deep learning, or still you have to go to Python for deep learning?
So it's funny because I have more or less like the same experience that you had. Like I used MATLAB 2, Python and R. So I learned Python before to learn R, and I have this feeling that there is like some analysis. It's much easier to do it in R, but sometimes, especially like for the speed or certain utilities, I feel like it's much more efficient to use Python or Julia, since like recently I was more programming in Julia. So like more recently, I'm working on a project, on a metabolomics project. So my first reflex is to use it like in Julia, because I know that it will be faster. I like the way you program in Julia, but also I feel like to do some analysis, because it's still a new programming language, they don't have as much as libraries than in R. So what I did is like a mix of both, so between R and Julia. So what is good to know about R, it's also that you can integrate like Python libraries, and you can do also with Julia. You can use like, basically you wrap your Python function in R, and usually there is documentation for that, and you can use those in R. So you can, when you do that, you will lose a little bit in the speed efficiency, but at least you stay in just one environment.
Oh, okay.
Yeah, I would say similar things. I mean, I started out, with Fortran, Pascal, S, then MATLAB, then R, and now Julia. And I've used Python mostly as a scripting language. So for me, it boils down to kind of like things like visualization. I find much easier in R. For whatever reason, I think I would say mainly because of the large number of packages that have been written for those kinds of things. But for high performance computing, like using some of those libraries, maybe Python or Julia are better. but you know, maybe there are others here who have other opinions too.
Thank you, Saunak.
So there's, I think there was a question earlier, and I don't think he is here anymore. Trayvon Giles asked if you can still use the help tab in RStudio for functions that come from packages that you install. I think the answer is yes. Is that correct, Gregory?
Yeah, it's yes, like to have a package, especially like officially, like in CRAN or in Bioconductor, there is a standard, and you must have a documentation that can be open in RStudio. Yes.
Other questions from the audience? We'll hang around.